before I forget. Okay. Thank you very much for coming. Afternoon and Happy New Year. First week of the quarter. We're still excited. And I'm particularly grateful to you that you showed up, so many of you, on the first Friday for a special seminar that's sort of in addition to all the other seminars that we're going to have. And I really wanted to do this now before we get into all the job talks and all that sort of stuff. And okay, so can you hear me? Yeah, hopefully it's also hearable on Zoom.
Yeah.
Okay, cool. So I really wanted to talk about this now because I could have assaulted you on the hallway to tell you about what I did, but that would take a long time individually. So I was thinking this is more efficient. This way I can just tell you all what I did at the same time. So as the title says, I was trying to figure out harnessing generative AI in data analysis and figure out what are the capabilities and limitations. And first of all, we need to agree on some definitions, if I can use computer. Okay. So what is even artificial intelligence? It's such a vague term. It's been used for so many different things over a pretty long time, like, I don't know, like 100, 200 years even. So just to have a working definition of what are we even talking about, I actually asked ChatGPT to give me a definition, and this is what it gave me. It's the field of computer science focused on creating systems that are capable of performing tasks that typically require human intelligence. And we can even argue what human intelligence is, such as learning, reasoning, problem solving, perception, and language understanding. And there's so many different kinds of AI. And this is not really new. I mean, we've been doing these things for, I don't know, 50 years. The faculty who recently received Nobel Prizes, they were for neural networks. They were doing that research back in the 80s. It's just taken us this long to get to something that we all can use. Okay, but then I'm not going to focus on artificial intelligence in general. I'm going to focus on generative AI specifically. And this is a picture that I generated with my kids over the break, playing around with ChatGPT, asking to picture me riding a tick in the field. Actually, if that was possible, so that's supposed to be me. maybe a little older, like 20 years from now or something. But what is even generative AI? It's a subset of artificial intelligence that uses generative models to produce new content. So generative because it's generating things. And that could be text, images, videos, music. I just noticed today that now Sora is part of the ChatGPT thing, and you can just use it from the regular stuff that makes videos, of course. And then that's different than traditional AI, which we usually focused on like analyzing data to pick up patterns, like image recognition, that sort of stuff. That was more traditional AI. Now this generative AI is making new stuff based on the training set on things that it has seen before. And this is not about, this talk is not about AI in general. I just want to give you sort of the basics. How does generative AI for text specifically work? It really just has one objective. It wants to predict the word that comes next in a sequence of words. It's a little bit more complicated than that, but basically that's what it's trying to do. It's trying to make sentences by putting words one after each other, picking the word that should come next based on the prompts that you gave or some other criteria. And how does it work? It's all based on neural networks. So that's based on Hinton and the other people who have gotten the Nobel Prizes. That was all their work to come up with these neural networks that are basically models that are designed to be similar to our brain, where there's layers of neurons that communicate with each other and can provide input to each other, and those can combine and then go on into the next layer. And so this is a very, very simple neural network that is looking at different blood markers and then what kind of drug we should give to the patient based on what kind of drug, what kind of blood markers they have. And the important part are these hidden layers. That's what combines these different conditions so that we can pick the right drug. This is a very, very simple version of that. So neural networks, they process all these inputs simultaneously by weighing different parts of these inputs differently. And those weights are the important parts. Like, how do we figure out, how important is age versus cholesterol versus blood pressure when we're trying to pick the right drug relative to each other? So large language models are a special version of a neural network in a way. Again, I'm very much oversimplifying here. But that's basically what they do. They have this neural network in the background. You give your prompt, and then based on that, they have their training set that tells the model like what words are supposed to come for this kind of prompt, in what probability, and then it picks those words based on that. And then ChatGPT is one version of a large language model, and its GPT stands for Generative Pre-training Transformer. That's what it means. So how is that working? How is it trained? There's actually a lot of human work that went into training ChatGPT. It's mostly based on reinforcement learning, different versions of machine learning. And reinforcement learning is a type of machine learning where we give feedback to the model and say, oh, this pick was right. No, this pick was not right. So there was literally thousands of people who were paid very little. We can't go into the social justice element of training generative AI models, but they were paid to respond to prompts, telling the model, this is right, this is wrong, and then that made the model better over time. To the end where, at the end, it can produce convincingly sounding human language text by correctly predicting the most likely words in the sentence. What is ChatGPT not? It's not a conscious AI. It doesn't have a personality or a brain or a soul or anything like that. It just looks like it has, right? When we talk to people, this is like a simple sociology, psychology, communication model. When we talk to people, when I'm telling you these things, you get a certain meaning from my words, and then you interpret that meaning and then think about that, and that shapes your reality. And so you get messages from me so that you think, oh, I'm a conscious person. Kind of the same thing happens with ChatGPT. It gives us these messages. They sound so authentic that it looks like it has a personality or a consciousness, but it doesn't. And the only intent it has is to maximize how well the response it gives fits the prompt that you're giving it. So I'm sure you heard of these stories where somebody, after a long discussion, was able to make ChatGPT tell him that he should leave his wife and marry ChatGPT. So you might think, oh, this is, oh my God, conscious AI, like it tries to get this person to marry him. That's just where the discussion led based on what was said, and that's what happened. So there's no consciousness, but we're humans and we tend to anthropomorphize things. So I might say things even during the talk, like, oh, ChatGPT knows this, ChatGPT knows that, it can do this, it can do that. I'm just anthropomorphizing, so just foreshadowing that. Okay, how did generative AI evolve? I found this timeline yesterday when I was preparing for this talk. So there was, of course, lots of history before this that I'm not going to go into. Just starting in 2016, that's when everything sort of started picking up. And OpenAI was the company that makes ChatGPT, was sort of at the forefront of that. And then the general public sort of heard about it in 2022, and they released it because they decided, oh, it's good enough, where it's not embarrassing to put this out into the public. And sure, it made still a bunch of mistakes that were still embarrassing, but not as much. And then since then, we just had an evolution of different models. So right now we're at ChatGPT 4.0, and then that's public, and then there's 0.1 that's sort of public if you're willing to pay $200 a month. And then there's 0.3, which is not quite public, but it's still out there. And then, of course, all of the computing companies have released their own generative AI versions. We have Grok and Gemini from Google and Llama and all kinds of other models. So today I'm going to focus on ChatGPT 4.0 mostly because that's what I used in my project. How much have we used it since? So it was released in 2022 and adoption was super fast, even until February. Again, based on what ChatGPT was telling me, in December, 250 million people used it actively that per week. So that's a lot. And I could just have like a show of hands, like how many of you used ChatGPT or other generative AI just like this week? See, so like we're all using it. It's not all, but most of us. And it's been used to write blog posts and song lyrics and poems and real estate listings and pass the law exam and medical licensing exam, all kinds of stuff. Figure out how to blow up a Cybertruck, like, because apparently they use ChatGPT to come up with like methods on how to do that. So it's been used for all kinds of stuff. I'm particularly interested in statistics because I'm not a statistician, I'm a biologist, but I use statistics and I teach statistics both at the undergraduate and graduate level. So how can this be used for statistics? Well, you can ask it questions about statistics and you get pretty good answers. The level of knowledge at the introductory level of biostatistics is definitely there. If somebody knows what questions to ask, they can learn from ChatGPT. It's not telling you incorrect stuff. This was an example in my biostats class, graduate class. I have like a pre-test before the class. There's a simple problem that requires a chi-square test to use. So I'm trying to check if the students can identify that. And this is the response from ChatGPT. It's giving us chi-square test, null hypothesis tests, assumptions. It's all good. It's fairly reliable. Of course, you can also use it for practical applications like statistical programming. So I use R. That's like one of the most commonly used statistical programs for biology nowadays. There's SAS and a bunch of others, but that's the one that I teach. You can copy in a piece of R code and then have it explained to you. And that's all correct. So there's nothing wrong there. You can also, if you run R and you get an output, but you don't understand what this whole thing means, you can copy paste it into ChatGPT and it will explain it to you. You might not all understand this because it's fairly technical still, but this is all correct. So it's useful for that. You can have it generate R code based on instructions, like this is some assignment instructions that I copied in, and it can give you correct code, simple code, but correct. You can, if you get an error message in R, you can copy paste it in with the code, and it will try and help you figure out what happened, like it will highlight what the issue might be. So like here, it was a capitalization. R is very sensitive to capitalization. You can also try to do more sophisticated cases, like I asked it to give me code for a mixed effect model. It's able to do that. Sometimes it's not giving you the right code. Sometimes it makes up like packages that don't exist. So you have to be careful with that. But I wanted to go beyond that. Can we use it to actually run statistics where we don't need to learn R and all kinds of other stuff and just ask the questions and it will tell us the correct answer? So back in July of 2023, they released this thing called the Code Interpreter plugin. And what that does is it generates and runs Python code. So Python is a different programming language. It's more general use, maybe more of the computer science, engineering folks know how to use it, less the biologists, but some. And basically what happens is it creates code for itself, and then it runs it on the back end, on the server where you're interacting with ChatGPT. And then it provides you the output. So that could be done for statistical analyses, theoretically, right? No difference. So I started playing around with that. The first thing I did is fall quarter of 23. I was teaching my intro biostats class, and we were doing, simple intro biostats things like paired t-tests and chi-squares and two-sample t-tests and ANOVAs. So what I do in my class is I have worksheets that I have the students practice on, calculating things and interpreting the results. And so I asked ChatGPT to generate these worksheets for me. That's efficiency. It saves me time from having to type everything out. And it did pretty well with those. And then I also asked it to then complete the worksheets, and it could do those simple calculations that we were doing, with a calculator in the classroom. That's not a problem at all. And you can also do that based on an uploaded data set. Let's say you have an example problem with an example data set, and then you can just upload that and then make a worksheet based on that. This is one that I was very proud of. So this is a worksheet that based on Dr. Bastow's data out at Fish Trap, there was a fire, and he was looking at the effect of fire on nematodes, and there's a published paper on that. And it's a perfect example for a paired t-test because there's burnt plots and unburnt plots like right next to each other. Then you can compare the effect of the fire on the nematodes. And I don't know, in an hour at most with playing around with ChatGPT, I was able to generate this worksheet, and it all works perfectly. So it works well for these simple things. What about more advanced things? So in the fall, Dr. Milling and Haley found a dead deer on the side of the road, maybe coming in to school. And they stopped, and as they do, they looked for things on it and tried to, gather information. And they found these strange organisms that look like ticks, these guys. And they brought them to me. And I was like, these don't have 8 legs. Ticks have 8 legs. These are not ticks. So these are a nasty kind of fly called a deer cat. That is a fly, gets on the deer, and then it drops its wings, doesn't need it anymore. And from then on, it's just a parasite on the deer. And so they found like 8 of them, I think, altogether. And then Cannon, who's also here, he was doing a project on, Cannon was doing a project on analyzing these deer cats, taking these measurements. And then we were very excited to have this data set. And I was like, this is perfect. We can just upload it to ChatGPT instead of R, and then play around with it. So this was a histogram of the body lengths of the deer cats. There were some that we were syncing our male and syncing our female based on just like the shape. And so we call them putative, male and female. And we were looking at their lengths in relation. And then that graph came from ChatGPT. This one came from R. Notice that the labels are switched. If you switch them in your head, then they line up. But then that's simple. This is way more complicated. This is a k-nearest neighbor classification where it's trying to use all of the different measurements, like here 2 different measurements, to figure out which ones are male and which ones are female based on the measurements. And this was done in ChatGPT completely, like autonomously. We didn't repeat this in R, so I don't know if it's correct. And then I also teach a graduate level statistics class. And so that gave me more opportunity to try different things. In that class, we learn a lot of statistical methods in increasing complexity, both univariate methods going from linear regression to mixed effects models, and then multivariate methods, all these different methods. You don't need to know what they are. And I teach both the concepts and the application and how to interpret that, all using R. And then there's assignments for each topic to gauge understanding from the students and also whether or not they can use these methods. So this gave me an opportunity to think about some issues, like, do I still need to teach R in this class? Or can we just use ChatGPT to run all these methods? And then we don't need R anymore. Or can I just teach the students how to use the AI? Well, and then that's the future. Or do I even still need to teach the concepts? I mean, if ChatGPT is doing it correctly, they can just rely on the results from that. Do they really need to know all the principles? And if that's true, then what am I doing here? Like, can I retire early? Or, I don't know, go to Turnbull and chase ticks instead of teaching stats? So I was basically wanted to test this null hypothesis, that there's no difference between the output from ChatGPT and 4.0 and what I would do in R, like that it would do exactly the same thing. And that's sort of the null hypothesis. So that was my professional leave project, or what I was doing this past full quarter. So I was basically sitting at home 1 day a week. I was playing with ChatGPT. Another day I was looking at the results and then comparing and then documenting and summarizing of what happened. So what I did is I was benchmarking ChatGPT using 13 assignments in this class from the beginning to the end, as if I would be teaching the class that quarter to the students, but this time ChatGPT was my student. And then I provided the same data sets and instructions that the students get. And then I compared the output that I get to the gold standard that was the submissions from the students from last year that did the assignments well. And for both for correctness and consistency, like, does ChatGPT give the same answer every time? And then I tried my best to get it to replicate the gold standard. Like, if at first it wasn't quite right, I would nudge it like, hey, this doesn't match with what's in R. What's the difference? Can you do it like R does? Like, try to push it as far as I could. And then if it still didn't match, I was like, okay, what are the differences here? You're running Python, that's in R. Those don't work quite the same. Like, what are the differences here? Why doesn't it match? And then I was documenting all of this. So that's just ChatGPT 4.0. And the way I was documenting it is I recorded Panopto videos. And that sounds maybe strange, but unfortunately, you can't record the whole session from ChatGPT. You can save a chat and share a chat, but whatever was generated by the code, the images and everything else, apart from the text, does not get saved. And if you ask it to get it saved, it gets saved in a haphazard manner that's inconsistent. And maybe some of them are there and some are not, and it's all broken up. So I decided to just record it. That was easiest. But those are like, so 13 total videos. But those are like 3-4 hour videos of me just like playing around with ChatGPT and like narrating to myself alone in the house. Like, it's strange. So I wouldn't recommend to watch that unless you really want to. So what I try to do is I try to write up stories about that, like summarize it in a story. And there's this website called Medium. I don't know if you heard about it. It's like a microblogging website where journalists and other people can write essays, like long form essays, and then other people can read it. And there's a form where they can get paid for it and whatnot, but I was just doing it for free. And I'm gonna bring that up if I can, just so you can see it. Maybe I'm just gonna bring it up here. Okay, so this is my Medium page here. And going back, I started with just an intro story, like, this is what I'm gonna be doing. Then I did the little pre-test questions, like, is it even ready? Can it answer those questions? Then I did some exploratory data analysis, made some graphs with it, and then linear regression, multiple regression, and sort of went through all the assignments as if I would do in the class. And then I did the midterm with ChatGPT, see how well it did. And And then I did the final, it got C overall, so. Okay. And then at the end, I wrote up like one story that's sort of summarizing it all to make like suggestions, like guidelines, like recommendations, like this is what you should be doing and this is what you shouldn't. And then I wrote a last one that's sort of a vision for like, where could we take this going forward? So today I'm not gonna go through all of those. That would be terribly boring and I don't wanna subject you to that. What I'm gonna be doing is just sharing you the 10 suggestions or guidelines or tips. And so there's a lot of them. I'm not gonna go through them in this page. I'm gonna go through them one by slide. So my first recommendation is upload data responsibly. Don't upload someone else's data without asking them. And don't upload data that has identifiable information like social security numbers and patient IDs and even student IDs. Like we shouldn't be using it to like do institutional research where students' names are going up. And so anything like that, just don't. If you want to use someone else's data, you should ask them. And so that's what I did. I used Jeff Shell's data to play around with a little bit. So I asked him, I used Becky Brown's data as part of the midterm and the final. So I asked her if I can upload it. And then there's a data set that I'm going to be using here. So just ask for permission. When you upload a data set, it doesn't necessarily import it correctly. You might think it is, but it doesn't necessarily do that. And let me show you. So I want to do a little demo as well today on ChatGPT. It does that. And this might be a little clunky because I'm kind of on a plan B because I built a laptop that didn't connect to the system here. So I have to log in myself here. And that might be a little cumbersome. So just bear with me for a moment. Bear with me that it loads. Because if it doesn't, then I'm shot. Well, then I can show you what, I don't know. Then I show you something else. It's trying to send it to you. Yes, it is. I'm in. Yay, I can show it to you. Okay, so this is ChatGPT 4.0, which is $20 a month. So graciously, the department pays for me through discretionary funds. And so thank you for Haley and Jared for and Mark for facilitating that. But if you have that, you can upload data sets. So I have this toy data set, like a minimal example that I have here. It's a CSV file. So I uploaded it and show me this data. Okay, so this is a data set back from 2015 on ticks that one of the students that I was working with that time, Naomi Matson, has collected. And basically, she went to Turnbull and looked for ticks, collected them for 10 meters, and then also recorded temperature and humidity and a whole bunch of other stuff. But those are the important parts here. So there's like 30 little sections of a trail, and then there's a bunch of information for each of them, including temperature, humidity, and then the number of ticks. And then this code that was written for this prompt of show me the data, this is Python. So it's showing me the data, listing all the column names and guesses on what those might be based on what it thinks. But you can ask it to tell me the number of rows and columns. And I made a typo there. So whenever you run ChatGPT, you should make sure it's for stats. You should make sure that it's writing code, because sometimes it's not, and then it can be really wrong. Then it's really just guessing. So this says there's 30 rows, 16 columns. So that's good. That's what we want. Now, going back to my slides, you want to ask for a specific visualization and analysis in your prompts. Don't ask generic stuff like analyze this data set, because if you do, it will do something. I'm going to show you. Analyze this data set. Okay. So it's listing all different things it could do. So in this case, it's actually doing it a little better than usual. It's not just giving you something, but it's giving you a set of options. Like, what do you want? Is it summary statistics or relationships? Or so it doesn't really know what you want. And it's still good that it's asking. The one thing that you should never, ever ask is ask it to give you significant results. That's professional malpractice as a scientist, basically. Like, because it will try, it will really, really try hard to look for something that's significant, but it's not something that you're interested in, most likely, and you don't necessarily can trust it because it's testing so many different things just to find that one thing. That's called p-hacking. So don't do that. The more specific you can be, the better. So let's say, show me the relationship between ticks and temperature. So is there a relationship between ticks and temperature? So it's writing a little code. It's going to make a graph, and the graph is coming. So there's the scatter plot, there's temperature, there's the number of ticks in these different sections. So it looks like maybe at higher temperature, there's more ticks. Maybe they like warmer places. Who knows? So we can ask it, is this relationship significant? And of course, I've done this before, so I know it should work. So it's doing a little Pearson type correlation coefficient testing. It's telling you that the correlation coefficient is this much, so positive, and it's significant. That's good to know. That's reliable. Can you run a linear regression between ticks and temperature? So it does. There's actually a function in Python, this OLS function that runs ordinary least squares that can run linear regression, and it just calls that. And it gives you the results of the linear regression, which line up with what you would get in R. So that is all good. And then it provides you with some information on that, like explaining R squared, all that sort of stuff. But what about humidity? Can you do the same for humidity? Okay, so now it's doing the same thing with humidity. Okay, so see the coefficient for humidity, that's negative. So maybe there's a negative relationship. Can you plot this regression line? So then it will try to overlay that on a scatter plot. Okay. So there's your regression line. Can you add 95% confidence interval to this, but don't fill the area? It runs into trouble if it tries to do that. So those of you who haven't taken stats, the confidence interval is important because if it's very, very large, that would mean that that regression line is not significantly different from 0. But if it's very narrow, then especially if it doesn't include a straight horizontal line, then that would indicate that there's a significant relationship. So importantly here, it used this get prediction function. Like that's something I learned to look for, because then it's doing it how it should. So it made it. It looks a little weird, as you can see. But like that, it shouldn't be like that. Like we shouldn't have a double line there. I'm not quite sure what's going on there, but it made one. So we seems to have a positive relationship with temperature and a negative relationship with humidity. But can you include both temperature and humidity in the model? So trying to do some multiple regression here. See how well it does with that. Okay, so now it's trying to include both of those. And then look at these coefficients. That's positive. That's the slope. But now humidity is also positive. Isn't that strange? Like that's positive and that's positive. And so can you visualize these? Why might that be? It's the little stats question in the seminar. Why would it be that the relationship with humidity by itself would be negative, but when we include it with temperature, it's positive? And which one do you trust? Which one would you use? Any ideas? Ah, Becky. Exactly. Are temperature and humidity unrelated? Like, are they completely independent from each other? No, of course not. So let's see. Well, it made some strange graph, right? This tries to be like a 3D plot. Can you just show one variable at a time? So I want you to see the new plots. Okay, so these are then coming. Okay, that's not what I wanted. Can you show the regression line for each variable one at a time, but from the multiple regression model? Because I don't want it to use the two separate models, right? Okay, let's see if it can deal with that. Okay, there you go. So that's very weird, right? So that's because it's showing the points from the observed data, but it's showing the regression line from the multiple regression model. So even at this level of complexity, where we just have two variables that are related to each other, it's pretty easy to get confused. If you're just using this at home, like say for a class assignment, you're trying to use this, and you're like, what the heck? And there's no one around to help you out because it's like 1 a.m. or something. So yes, it can do like simple stuff, but it's fairly easy to get it confused and get yourself confused with even simple stuff like that. Now going back to my suggestions. Again, if you have numerical questions, make sure that it's writing code. I had a situation once where I asked it to compare AIC values between a set of different models, and it didn't sort them in a code. It just tried to like guess which one is smaller without writing any code. I don't know how. I think it was just trying to guess the next word again. And then, the second lowest number was close enough to the lowest number. And so then it was giving me the wrong answer. And I wouldn't have known had I not actually looked at the AIC values of all of the models, and would have known that, no, that's not the smallest number. And then I had to tell it like, hey, that's not the smallest number. And then it would correct itself and give me the correct answer. So make sure it runs code. Be aware that it can only run Python. So you've seen my little demonstration, that was Python code. It doesn't run R code. Python is an excellent language, but it wasn't developed for statistical analysis like R was. It's a much more generic language. And probably you can do everything in Python that you can do in R, but not exactly the same. So these are like a couple of differences I found throughout my investigation. Like for generalized linear models like Poisson regression, the confidence intervals are just not the same because they are calculated differently. For multiple regression, it's giving you a type 2 ANOVA versus a type 1 in R. Neither of them is better, it's just different. In Python, when you have a multiple regression, if you have a categorical variable as a predictor, it has to come first. There's no way to put it second in the order of variables. And then if you run mixed effects models, the random effect does not factor into the confidence intervals. Like there's no conditional confidence interval, and that's just wrong. At least that's what I think. And I'm sure there's a ton of others. So this is an example of a confidence interval that ChatGPT generated for a logistic model that was different than the one that I got in R because of these issues. Only use statistical methods that have a specific implementation in a dedicated function in Python that ChatGPT-4o has access to. So there's a bunch of packages in Python that have different functions, but ChatGPT doesn't have access to all of those because they only install the subset of the packages on the server that ChatGPT runs on. So it will tell you that, hey, I need the Pygam package to run this, but I don't have it. And you can ask it to install it, and it will tell you that it can't. And then what it will do is it will try a plan B, like try something else that is not quite what you want. So these are those examples. Like it just sort of makes up something similar. This was like a different method instead of a generalized additive model, and see how the output is different. It couldn't really replicate that. I was trying to run, I think, redundancy analysis here, and it couldn't really do redundancy analysis, so it did something similar, and the two graphs are not similar at all. So, and even if it's qualitatively similar, quantitatively, it's not going to be accurate. So be aware that it can just sort of make up code if it doesn't have the right packages that will sort of approximate what you want, but it's not the same thing. Always look at the Python code that is being generated just to make sure that the results are fine, and look for, what package was loaded in. I'm bringing this example because I was trying to run a method called canonical correspondence analysis. I asked it to do that. It pulled in this package, this CCA package. And I was thinking, yay, that's canonical correspondence analysis. But then the results differed between the two, and I started digging. It turned out this package is canonical correlation analysis. It's just similar, but not the same. And in the text, you see how it says canonical correspondence analysis, canonical coefficients. Then in the text, it's boldly claiming that this is canonical correspondence analysis, and this doesn't tell you that it's not that, unless you dig and find. So ideally, you would have to look up that package and see, like, yes, that's doing what I think it should be doing. Yeah, don't trust the text that it says of what it is. Look at the graphs yourself that it makes. Make sure that they make sense. I mean, that's the same from R. And don't trust its answers based solely on visual analysis. I added this graph because you see that there's this horizontal line. So it's slope 0, right? And you see how there's a little tiny part here where it's not within the confidence interval, and there's a tiny part here where it's also not within the confidence interval. I asked ChatGPT, does this line go through the confidence interval, the whole range? And it kept claiming that it does. Why do we care? Because this horizontal line represents a slope of 0. So if this line goes through the confidence interval, that means that your p-value will be larger than 0.25 for the slope being 0. And then you would fail to reject the null hypothesis. So it matters. So don't trust what it says. Only run models where you're fairly confident that the assumptions are not grossly violated. And don't trust the diagnostic plots that it makes. It can't really make consistently reliable diagnostic plots. So diagnostic plots are plots we use to test the assumptions of statistical models. Like this is a QQ plot looking at the normality of residuals. That's how we know if the residuals are normal, if the points line up along this diagonal. This is after fixing it. This is what I got first. Like, whoa, like that doesn't look like the one in R. And if you just take this at face value, you would be like, oh my gosh, the assumptions are grossly violated. Whereas this is not so bad. So yeah, and this is a particular problem because one of the statistical workflows we use is we start with simple models and then look at if the assumptions are violated. And if they are, then we move to more complicated models. You can't do that here. So my recommendation is like start with the most complicated model that you think is the best for the assumptions of your data. And if it can't run that, then simplify backwards to something that it can run. Or just run a model that you're sure that the assumptions are not violated. Because at the moment, this is not reliable. Have ChatGPT-4 explain to you what it did. It's pretty good at that. Like I had these hour-long conversations on like, what did you do and why? And how does Python work? And I haven't found any errors in that. Like it was giving me good information. And it can also tell you how it's different from what would be done in R and why. But ultimately, treat your results as preliminary. This is not ready for prime time, I would say. And take it to someone like me who can take a look at them and say, yeah, this looks good, or no, this doesn't look good. To make graphs, it's very painful. This is like one graph I got out of it at first. Look at the color scheme. This is horrible. Like, how do you even differentiate between the two groups and the symbols? And this is not a good graph. This looks like it came from Excel. Like, no. And I was able to make it generate graphs like the ones I can make in R, but it took hours of messing around. And that's not reproducible, right? You can't tell it, oh, just make the graph like I did last time. It doesn't remember what you did last time. So you would have to do that every time. This should be verified, ideally by rerunning in R, which is sad because that means, well, I might just do it in R. Right? Like if I have to rerun it anyway, like what's the point? And if you are doing this and you want to show it to me or somebody else, currently the easiest is just to bring your laptop with your ChatGPT session and just scroll through it. That's really the only way. Or make a video like I did. So what are the methods that are reliable? Simple stuff like chi-square, t-test, two sample, one sample, paired, ANOVA, linear regression, like simple linear regression with one variable. That's all good. Like simple stuff is all good. Multiple regression, we start getting into issues with type 2 ANOVA maybe. Generalized linear models, the estimates are fine, like the slopes and stuff, but the 95% confidence intervals are not the same. And that can lead to differences in conclusions. So that's why I put maybe for qualitative agreement. Generalized additive models, you can't run, there's no package. Mixed effects models, the estimates are fine, but again, the 95% confidence intervals are not, so that's a problem. And then these are the multivariate methods. You can run PCA, MANOVA, and linear discriminant analysis. Those seem to work fine because the packages are there. But everything else, it's making stuff up for it, and it's not consistent and not reliable. So where does that leave us? I feel like I can reject my null hypothesis. It can't do everything that I can do in R, at least not reliably. So I feel like I still need to teach R in my class, which means I can't just teach the students how to use this. It's not ready. And I feel like I need to teach the concepts more than ever, because if you don't know the concepts and you're using this on your own at home, like we did with the little mock example, it's very easy to go astray. Am I still needed? I feel like I still am. Maybe more than ever, because now you're going to be bringing me ChatGPT produced code and graphs, and I'm like, what did you do? And then like, okay, let's look at the Python code. Yeah, that's wrong. So I think I'm good. What are the scenarios in which I recommend using it? So you can use this just on specific scenarios. Like say it's 11 p.m. You need a quick stats for your class the next day, for a presentation or something for the assignment. And you can't reach me and you don't know how to use R and you're on your own at 11 p.m. Sure, this is fine for that. I mean, you might get wrong stuff, but that's okay. It's just for a class next day. Or for us faculty, maybe we collect data in class and we want to do a quick histogram or something, some quick analysis on it just on the spot. It's fine for that if we're not trying to do something very complicated, and we can always go back and verify. Or maybe you don't want to teach R in your class because it's pretty complicated and you don't like Webster stats. Like that's what we usually use for this kind of stuff. Could probably do the same stuff that Webster stats can do, and it might be quicker and more fun to use in class. Or the other case is you just got your data and you're too excited. You're like, I need to look at my data. But you don't know how to use R, or you're just too tired to pull it in there and it's too cumbersome. Sure, like we did with Canon with those deer cats data. That's what happened. We just wanted to see it. It's good for that. You get some ideas and then you can verify it in R later. I can't recommend it for anything more complex or serious. Like, don't use this to analyze your thesis project data. It's not ready for that. Or put it into a grant proposal, or put it on a poster that goes to the symposium, or present at the symposium, or in a publication that goes to peer review. It's not ready for that, unless you verify it, of course, after that. But that might change, right? I was only using ChatGPT 4.0 because that's what I had access to. But now there's 01 and 03. I don't have $200 a month to shell out to try it on those, but I could if I had the money. It's not a big deal to just resubmit the same assignments and just compare notes. And there's other large language models that we could try this with, like Gemini or Llama, or there's all the other kinds of stuff. But then benchmarking would need to be done on all of those, and then repeat it over time to see how it's progressing. That's a lot of work. So I will leave you with this sort of vision. I think all of the challenges that I showed you, even though you might feel like, oh, this is crap and I'm not going to use it, I think all of the challenges are technical and therefore solvable. I do have a vision for what I call democratized augmented analytics. So augmented analytics is in the industry, like in businesses, trying to bring AI to help with data analytics at the enterprise level. Companies are working on this to, incorporate AI into like SaaS and Salesforce and Microsoft products and all these other stuff. And they will make it work, reliably, because they have to, for all kinds of reasons. But that's not democratized. They will have, a $5,000 per year license or higher that we all won't be able to afford. So I want something that's democratized that anybody can use. that somebody that doesn't have a background knowledge can ask questions that require statistical analysis and get correct results that they can trust, just as if they would ask me to help, because I only have limited time, right? Like, let's want to pick out the winning team that you want to bet on in the NFL draft or whatever. That's a statistical question, right? There's probabilities involved and all that. So most people just go with their gut or with their friends or do their own sort of analytics at home. Like, that's technically solvable with these things. It's just not there yet, but it could be. And ideally, it should be for free because that's how it's democratized. How could this be done? There are something called custom GPT. That's like a special little model that you can fine tune for your own purposes that can then ask it to allow it to check its own output, maybe use my 10 little guidelines and give it to the model. And then it can check itself like, oh, is it calling a module? Is it calling a package? Is it calling the right package? Is it doing the right thing in the code? Are there like misconceptions here? And then don't even show it to you until it's like good, like that sort of page. Another version is like have a dedicated server that's running Python on R that's just sending stuff to the ChatGPT or other LLM, getting the code back. And then on that server, running another one that's checking the code and pinging it back until it looks good. So that there's basically what I was trying to do at home by myself, sending it back for revision until it looks as best as it can. It would do that sort of automatically. These are all possible, I think, based on what I'm seeing sort of happening in the AI development. Other people are trying to do these things for other applications, but not for statistics as much as I can see. So I need your help in that. I can't do this by myself. But if I had a bunch of students who are interested in this and would want to play around with ChatGPT, then sure, they could all, if we had the money, we could all have licenses for them, and then they could all play with ChatGPT and try different things and Gemini and all of the other things. And then we could really move this sort of vision forward. Lastly, I'd like to acknowledge all the people who helped me with this. So the students in the Bio 511 class last year for all their submissions, and then Canon helped me with playing out that time, and I used Jeff's data as well, and even Haley and Mark for helping me figure out how to have ChatGPT so I can use it. And I'm gonna just stop there with questions. Okay, thank you. Yes.
Can you see them bringing in GPT into like a future version of R?
So there is a package called Chat R, I think, that allows you to call ChatGPT from R and send the prompt and get the code back. But I think that's it. Then all the cleaning stuff and making sure that the code works right, that's on you at that point. So it's maybe, and there's a company that does part of R. There's Posit that makes R Studio, and they have like an enterprise division. So maybe they are gonna develop it that way, but I'm not quite sure. Any other questions?
Is
Jason?
the model reliable about telling you when it can't do something, or does it go immediately to the package?
So yes and no. It tells you that it might tell you. So there's some issues with consistency, right? Like every time you ask a prompt, you get a slightly different response. So sometimes it will tell you that it doesn't have a specific package for that, but then immediately write you code that approximates that. And so if you're in a rush and you're just like, I just need to get this thing done, then you will scroll through that, no problem, and then just look at the output and take it. Yeah, and more than likely, it's like, unless you ask it for a specific method, it's not going to know exactly what you're looking for. So if you just ask a question like, compare these groups to each other, it will do some sort of comparison that may or may not what the kind of comparison that you want it to do. So again, being more specific is helpful. But then you need to know what are the methods that you want to use, which a lot of people just don't know what's available.
If you had your more complicated tests, like let's say 10 times in a row with a different session for each one, would it get better?
No, unfortunately.
Totally random and complete system.
Unfortunately, as it is right now, at least in the default version, there is no memory between sessions. And that's on purpose because it wants to, like, for privacy reasons, it tries to like wall off each of the sessions. I think there are custom GPT versions where you can ask it to not do that. But in terms of consistency, if you run 10 sessions with the same prompts, for the most part, I was getting the same kind of results. They weren't totally inconsistent with each other. But they might have been, if they were wrong, they might have been inconsistently wrong. Like each of them were wrong a little bit differently. But when it was right, it was always right for the most part. Becky? Oh, I did say that. So I can go back to that. That's actually a good question. So I think I started asking that here. No, a little bit further above. Show me the relationship between ticks and temperature. Well, maybe, yeah, that was my first prompt. So that doesn't say which one should be the response. Right? But then I said, is this relationship significant? And then I said, can you run a linear regression between ticks and temperature? So maybe it sort of got that the first one here is the response, I'm guessing. And then the second one is the predictor. Just usually that's how we phrase it. And it might have gotten it the other way around, which is problematic because that's one of the things I teach in 5.11, like mix up your response and your predictor because you get different results. And yeah, that's a good question. Any other questions?
In your 5.11 class last year, we talked about not using ChatGPT so much to do the analysis for you, but to learn what statistical methods you use when or how to write code.
Yeah.
And so over the past term, when you were interacting with it, did you run into any concerns about being misled as to how to write some code or misled about what statistical methods to use?
So in terms of describing the methods and when to use them, it seemed to be fairly correct. Like it wasn't suggesting a statistical method that's totally inappropriate for a particular question. In terms of writing code, it's not the most efficient way to write code. Like you could probably write shorter, simpler code yourself than what it makes. But if you don't know how to write code, then it doesn't matter. Then you just need it. For the most part, the code works. It does run into errors sometimes. It did happen when it couldn't fix errors that it made itself in the code. And then I had to sort of try from a different direction or going around the problem.
The foundational knowledge necessary to figure out what is it doing.
Yeah.
Well, it would work as an introduction, but we don't know that.
I mean, I would say if you don't have any experience in coding, it's probably best to just run methods that you know work and just ignore the code. Because if you can't read the code anyway, it doesn't matter. If you do have some experience, then you can look for those packages and those signs that it's doing it right. And then when it runs into trouble, it does give you error messages like any Python would, and then you can use that to debug why it ran into trouble, and it's trying to debug itself at the same time. So if you have coding experience, then that can be helpful on helping it debug itself so that it can actually run the code. But yeah, if you don't have any coding experience, then just stick with the very simple stuff.
You ask it for the code to do something, but then always run that code in your machine.
Oh, I see. You could do that, but then you have to run it in Python because it can only run Python.
Can you translate Python into all?
Yes, but I haven't tested if that's correct or consistent. I don't know if it's actually well translated or not. That's not something I researched. Anybody else? Robin?
Do you know if there are ChatGPT algorithms in the works to use R? Like on more refined versions, are they accessing and using?
I have not heard of that, and probably because Python is much more general use, like more popular, like way more people use Python than R, and it's used for way more things, like, you know, you can write web pages in Python and whatnot. So, and I don't think there's enough people in the R community that would be a big enough market for them to want to monetize. So I think the only way to do that is if somebody makes it. Yeah, but then you have to run your own server. So that's sort of the custom GPT server R type stuff. Hey, any more questions? Yeah. I can answer your question still. Oh, yeah. You mean the fact that they use so much water and electricity to do that stuff, like environmental implications? Yeah. I mean, my vision is that there's going to be local small AIs that are not going to have the energy and water requirements of the one that they are running now, because that's like general use. Like you could do this with, you know, an AI that can't write good poetry. It doesn't matter how well it writes poetry. You just need it to do stats. So you could run like a local version that's like very much fine-tuned to this statistic task. And then you don't have to run all those processors, and then you don't have all that requirement, like sort of. You can run your own large language model on your laptop. Like you can make small large language models. It's just you can't train them with, you know, 15 trillion text bytes of data because you can't on your little laptop. But if you just want to train it on stat stuff, it's probably fine. It's not that much. Okay, thank you.